Hello, viewers. This is Chetan Kumar again from Stiblop Academy and Consultancy. I welcome all of you to yet another session of the product design and development. In today's session, I am going to teach you about the design criteria. So, before jumping into the preliminary design and development, which is the next phase of the concept design, I want to tell you about the design criteria. I hope you remembered my last session on the interface management. So, can we recap a little bit on the interface management? What is the interface? The interface is the marriage point between the systems or within the systems. So, the between the systems, we call it as a primary interface, and within the system, we call it as a secondary interface. Why are the interfaces important? They help us to establish the design intent, they help us to establish the system agreement, they help us to establish the packaging requirements. Okay, so this was all about the interface management. So in today's session, let's jump into the design criteria, that is advanced design criteria. Yeah, let's move on. Advanced design criteria. What is advanced design criteria? Advanced design criteria are those aspects of the design which should be adapted during the preliminary design and development in order to increase the maturity. What happens in the concept design? In the concept design, we get the shortlisted ideas, we apply our engineering basics and our creativity to achieve functionality, workability, and durability. So, in the preliminary design and development, we have to apply some advanced design criteria in order to bring in the maturity of the design. Let's see what are those advanced design criteria. They are design for packaging, design for manufacturability, design for assembly, design for serviceability, and the maintainability. Now let's look into each of them. The first advanced design criteria that has to be adapted is design for packaging. What exactly design for packaging means? It means that we have to package the design of our component or a system in a predefined confined space of that entire system, so that the geometry of that particular component or a system should not clash or should not interfere with the confined space of the adjacent component or a system. Now, let's try to understand this with an example. Imagine that you are going for a travel and you pack your luggage. How do you do that? If you carefully observe here, you have kept the shirts at one corner of the luggage bag, followed by the trousers, then the innerwear, then the towel. And beside the shirts, you have kept the footwear, followed by some exterior kit. And on the other side, you have kept the cap and the ladies' purse. Okay. So, similarly, we have to do the design for packaging. So, let's try to understand what are the main rules that we have to follow to achieve this. The first main rule is control of the geometry. As I explained before, we have to design our component in such a way that the none of the geometry parameters interfere or clash with the space envelope of the adjacent component or the part. Here, when I say geometry, it means the length, width, and the height. And also, there could be some of the projections which could come outside and interfere with the adjacent space. Okay, the best example for this is the front portion of the car. You can observe here that there are several components. So the engine is placed right at the middle of the car in order to achieve the center of the gravity demand. And on either sides of the engine, we have the battery components, we have the oil sump, we have the washer reservoir, we have uh, the engine coolant reservoir, and so on.
And we can also see a lot of other components here, electrical components. So this is packaged in such a way that none of the component interferes with the adjacent component or the system. Second example that we have here is the complete interior system of the car. You can see that we have the seating system, we have the steering system, we have the space to package the powertrain, we have some leg rooms as well, and we have the dashboard. You can observe that there is some gap between the driver and the co-driver seat. So this gap is meant to package the armrest. Okay, and we can, in case of the driver seat, there is enough leg room so that the driver can operate the accelerator, brake, and the clutch comfortably. And there is a pass through in between the front row seats and the second row seats. So this pass through is having some dimension. So all these things are taken care at the time of design for packaging. Basically, design for packaging is mainly applicable for the top-down approach. We have to strictly follow this while adapting the top-down approach in our design. Now let's look at the second advanced criteria. The second advanced criteria is to drive the interface locations. What I exactly mean by this is there could be some packaging requirements which can drive that interface location at any point of the vehicle. I hope you remember this bicycle. Now carefully observe one of the interface here. This interface is the rear driving system, which is in between the rear sprocket wheel and the body frame. This interface is placed in the middle of this body frame and at a certain distance from the rear wheel. Okay, so this is packaged here in order to drive the rear wheel. Okay, and this interface drives the interface of the cranking system. The cranking system, in order to get aligned with this rear driving system, has to be placed at a certain distance x from the middle of the frame. Okay, now let's take the second example here. This is a scooter. All of us know that. We can see that none of the interfaces are placed in between this handle and the seat because this space is meant only for the luggage, and this is that packaging requirement which drives to keep the engine interface nearer to the rear wheel. Okay, now let's move on with the next design criteria. The next design criteria is effective space utilization. So this means that whatever the space is available for us, we have to effectively utilize that to design our components. The best example is the battery kit for any manually driven bicycle. So this guy is Guru Saurabh Singh, who invented the battery electric battery kit for the manually driven cycle. He observed that there is enough space in between these three members of the bicycle, and he can place the battery kit right exactly here. And this product became very popular in the market. Okay, the next example that we have is the boot space available to keep the luggage in the Tata Nano. What we observe here is the engine of the Tata Nano is packaged at the rear side. In spite of that, we have enough space to keep the luggage. The next, sorry, the next design criteria that has to be followed is design for manufacturing. What exactly I mean by this? We have to design our component in such a way that it is easily manufacturable. Okay. Before we do that, let's see what are the main rules. The first rule is the choice of material. You have to decide which material should be used for your component, whether it should be plastic material or whether it should be metal material, because the manufacturing processes for both of these materials follow differently. The manufacturing process for the plastic material is injection molding and compression molding, and for the metal component is casting, extruding, stamping, and forming. There could be other manufacturing process like the fabrication and things like that, but they include joining of the components. Okay. Now let us see what are the design modifications that we have to adapt. Now let's take a plastic component here. So this is a simple plastic component, and what we observe here is in the concept design, this is just made like this. Okay, a boss and a shoulder and a hole. And so during the preliminary design and development, we provide the manufacturing feature for this, that is a draft angle, so that this plastic component can be easily pulled from the core. Okay, the next component that we have is a metal component. Okay, now if we follow the stamping process, there also there should be some draft angle to draw the component easily. Okay, another problem that we generally face is the spring back. Post bending in a V bended material, the component tries to retain its original shape. So, in order to compensate for that, the bend angle is reduced slightly so that after bending, we get the correct desired design angle. Friends, you have to remember one thing, that we should never think about all these advanced criteria rules during our concept design, because the concept in during the concept design we have to keep in mind only two things. One is the functionality, another thing is workability and the reliability. Okay, now let's see what is the next important advanced design criteria. The next important advanced design criteria is design for assembly. Okay, what I mean by this is you have to introduce certain features in your design so that the assembly could be done very easily. The first rule is location for assembly. Okay, so this is very much important when you have the bottom up parts, not the top down parts, bottom up parts. For example, this is the divider of our fruit auto sorting machine. So this is the concept design part without anything. But if you look at the preliminary design part, this is having the locator and also two interface points. Why this locator is provided? This divider is mounted onto this pink part of the stand. Okay. In order to locate it at this location, we should have a small stamped feature like this. If you don't have this feature, then one person should hold it by hand, and he should and another person should screw it. But by introducing this locator, a single person can assemble this onto the stand. Similarly, you have the locating pins on the assembling fixture where you place the parts one beside the other by means of those locating pins. Okay. The next rule that we have is sequence design. So let me explain this with the model. So let me swap to the model here. This product is the card holder. The card holder consists of two systems here. One is the vertical stem, which can hold the card on the top, and another is the frame arrangement, which can facilitate the to and fro motion for this vertical stem, like this. I hope you're enjoying this. Now, let us come to our main point of discussion, that is sequence design. Now, imagine that these L brackets were integrated along with this C channel frame. Then, do you think that it would have been possible to insert this nut kind of part inside this? No, because there is no room to insert this at all. Okay, so that's the reason you have to split these two walls in the form of L brackets so that you can assemble this sequentially. Now, let us look at the assembly sequence of this. Okay, first of all, this L bracket has to be fixed, and then this has to be inserted from here. Only after that, you can insert this L bracket, and then you can insert this screw system. So, this is why the sequence of assembly plays an important role in the design, which should be adapted. Okay, by mistakenly, if we integrate these two walls as a part of this design, and if we assemble everything and send this to the manufacturer or the assembler, they will definitely raise a concern on this. Okay, now swapping back, the next important rule that has to be followed is the mistake proof or a Poka-yoke solution. What this rule says is that the correct or the right male part has to be fitted into the required female part. This one. If you try to fit this male part into this female part, it will not fit. Because you can see that this slot is smaller than this slot. And this male part can enter only into this female part. Okay. So this was introduced only to avoid the mistakes of fitting the right side part to the left side and the left side part to the right side. Okay. Moving on, the next advanced design criteria that needs to be adapted into our design is design for serviceability and maintainability. For a healthier running of any system, we need to ensure that it is properly serviced and maintained throughout the tenure. Okay, so that is exactly what we mean by the design for serviceability and the maintainability. There could be some parts which has to be frequently replaced. There could be some parts which service the environment, and those parts need to be designed in such a way that they effectively serve the environment. Okay, and there could be some other parts which are designed for a frequent inspection. Okay, so considering all those aspects, the rules are framed to adapt design the serviceability and maintainability in our design. Let's look at the first rule: frequent replacement of the parts. As I was mentioning, there are some parts in the system which has to be frequently replaced. What are those parts? Let's take this example. So this is the chassis frame of a Hero Honda Splendor bike, which I found it on the net. Okay. So if you look at this particular area, so there is a room to fix the air filter on one side and the battery on the other side. The body frame it is designed in such a way that it can facilitate the mounting of both. Okay, so this is what it is. So on the left side of the vehicle we can find the air filter, and on the right side of the vehicle we can find the battery which is mounted in this particular area. Okay, so this is a provision that has to be provided in the chassis frame, where the cover for the filter and the battery frame can be mounted at these mounting locations, and they can be easily removed with the help of the key itself. Okay. Now let's take a look at the next rule. The next rule in the design for serviceability and the maintainability is to facilitate the service. As I was mentioning before, there are some components which are designed to serve the environment, and for their efficient and effective serving, we have to modify certain areas. Okay, let's try to understand that with the example. So let's take the example of the elephant. So just observe the head of the elephant. The head of the elephant is facilitated with a trunk to lift the prey and feed to the mouth. But this is not the case with the cow. The cow is having a long neck and the face which is attached to the neck. Okay, but the head of the elephant is at a longer height as compared to the cow from the ground, from this particular ground. Okay, so if the elephant were to have such a long neck, then it would have been very difficult for the elephant to bend the head all to the ground and to pick up the prey. So, if this was the case, then the elephant would have suffered with the neck pain during the course of time. That's the reason it is having a trunk to pick up the food for itself and feed it to the mouth. So, this is one of the best example that we can find in the nature, that the nose of the elephant is designed even for the serviceability, because the primary function of the nose is to breathe, whereas the secondary function is to service the food to its body. Okay, and the real practical examples that we have that have been designed from this particular example is one, this one, the flexible shower pipe. The main shower cannot reach all the parts of the body. That's the reason the flexible pipe has been designed in such a way that it can reach, or it can serve the water to those parts of the body where the main shower cannot pour the water, like armpits. Another example is this toilet cleaner, Harpic. The neck of the Harpic is designed in such a way that it can reach to each corner of the toilet. Okay. Moving on, let's look at the next rule. The next rule is facilitate inspection and maintenance. As I was mentioning before, some parts have to be designed in such a way that they have to facilitate frequent inspection. One such example that we have is the manhole. The manhole is designed for the frequent inspection of the filling of the slurry, or whether it is blocked. If it is blocked, it can be removed and cleaned easily. Okay. Now you can raise a question that why the design criteria is to have a circular hole. Why not the rectangular hole? If it was a rectangular hole, and if there was a rectangular cap, then it would have fell easily inside this. So that's the reason for a frequent inspection they have designed this manhole circular. Okay. The next rule that we have in the design for serviceability and the maintainability is standardization and commonization. Okay, now let's look at this example. So this is the lock that has been designed for the two-way door system. One of the bracket is mounted to the left side door and another bracket is mounted to the right side door. And we have the latch which can lock the door by means of locking of the bracket. And the lock can be uh, inserted underneath and it can be locked. It can lock the door. Okay. Now, if you carefully observe this bracket, so this bracket is having the slot on upper side as well as the lower side. Okay. So that It can be used on both the sides. And also this hole. The hole is provided on the bottom side. So if the slot is provided on both the sides, the latch can be locked inside this slot. Okay. So if we standardize and commonize the part, the serviceability cost comes down. So this is the last rule to achieve design for serviceability and maintainability. Thank you viewers for watching this video on the advanced design criteria. I hope you enjoyed this video. If you have any questions, please post them in the comment box. Take care. Bye for now.